right. Thanks for coming. I got a couple more stragglers here, but so we're going to talk a little bit about how to use distributed tracing in your application today. But as we do this presentation, we're going to do a quick presentation with some topics, and then we're actually going to get into kind of the demo. We need your help as part of this meetup. So there's a URL up there, right? shirts.beachops.io. Go there. It's mobile ready. Get a T-shirt. No, you're not going to get it. It's not going to actually ship. We don't have credit cards. But this is the app that we're going to actually talk a little bit about and kind of relate back to it for context throughout this presentation, okay? Okay. So again, it's t-shirts.beachops.com. So let me start quickly by talking a little bit about myself and the team and my colleague here. So I run a group of developer advocates at VMware. Our job is to really help users like you, in a general sense, learn about how to develop, build, and deploy and kind of manage applications on the public cloud. Yes, we exclusively actually look at Amazon, Google, and Azure because we actually do support quite a bit of that, and that's something that we're bringing up from a capability perspective. We have a website where we put our blogs and solutions and topics, and they're not about VMware, actually, and some percentage, smaller ones, are about maybe 30 to 40. A lot of it is also about some general topics and ecosystem components like tracing itself, how to use Jaeger and some other things. So take a look at it. It's cloudjourney.io. Follow us on Twitter. Follow me at Shetti. And then my colleague here, Sushant, he's one of our engineering managers on the product that will kind of walk you through and show you how to use some of that data from tracing. Just a note, this is actually a follow-up meetup from one we did earlier at Reactor about 2 months ago. And on our site, we actually have a link where in the first meetup what we did is we talked about how to effectively code tracing bits, Jaeger, right, and open tracing into your application with Go, Node, and Python. So there's just a lot of information about how to do it. We decided to put it together, and then this is the follow-up on, okay, now that you've built it inside, what do I do with it, right? So hopefully that makes some sense. And obviously, as we sort of do this, we're going to use that application, right, the BeachOps, a T-shirt app, and kind of walk through that, right, and talk about a scenario. So as you're using this app, you'll probably see some issues that pop up, so we've kind of built in some problems, and then we'll kind of talk about it, and Sushant will tell you how do I pinpoint that problem using tracing, right? And before I do that, I'll talk a little bit about some basics, right, just to kind of bring everybody up to speed, a little bit of the ecosystem, and then we'll get into it, okay? So, just double checking. You know, apps have changed a lot, obviously, over the last 20 years, right? They used to be monolithic, multi-tiered, and now you basically are deploying some sort of microservice-based distributed application, right? That's potentially running on-prem, in the cloud, wherever it is, with lots of different components, lots of different languages, and it's a challenge to sort of manage this, right, from multiple fronts. Particularly, I guess, you know, one of the areas obviously we're going to look at is how do I actually understand what the issues are? How do I analyze the problems that are coming out? What are the best sort of like the practices, right? And that's sort of something that we're all sort of struggling with. And that's where tracing sort of fits in, right? In order to do that, I think there's a couple of topics that we always look at, right? One is obviously metrics, right? And if you think about metrics, what are they, right? It's a numerical representation of data that's measured over a specific time frame. And that data is going to give us information about something in the past, the present, and or the future, right? It really depends on how we analyze it. But we can also get, with all of that data and the metrics that come out, those key value pairs, an ability to correlate that data with other bits that we're seeing predictively or currently. And to do that, you're going to need some computational mathematics, some equations, or, and as we'll show you today a little bit, one of the tools that we have, what we're going to show is Wavefront. That actually helps do that and solve that for you in a very simplistic way, right? So metrics can be very powerful if they're used correctly. And we're going to use an analysis of the application. We're going to take some of that data and we're going to use charts, right? One particular one is, obviously histograms, right? And why are they important? I mean, as we've all taken stats before, right? But they basically help us understand a few things, right? One is when they're deployed, we take a look at the data, we can actually understand with the data how to understand the distribution of that across multiple sets or bins or whatever you want to call it. We can understand anomalies or outliers, right, of information. We can also understand percentiles, right, and understand data in a much more useful fashion than just taking a look at it in some other charts. So histograms are a very specific way of looking at it, and that really helps from an analysis perspective, right? And finally, there's tracing, right? And so I think the best analogy for this is, the way I think about it is an ability for you as a developer or a DevOps person to understand an end-to-end story about what's happening in the application or a specific component of the application from one point to another, right? A great example, and if you come to the VMware website or some other locations, you'll find this example, which is if you're using Uber, right, and you're using your application, you're using your phone, you ask for a driver, a bunch of calls and a bunch of components underneath occur, contacting the driver. The driver gets called, he comes over, picks you up, he says he's got you, you sit in the car, get to your destination, you get out, you get a charge on your phone, and that's it. And that end-to-end set of events, right, sort of like a transaction, is actually called a trace, right? From the point you clicked, the point you got charged. And there's a multitude of things that happened in between those 2 points. And so we have the trace of that end-to-end, but those components underneath are called spans. And this is very important because visually seeing what happens to sort of that transaction, right, is very important from obviously a visual perspective, but it also helps collect a lot of information inside of it in giving you an ability to kind of troubleshoot your application. You can see where things are low latency, and things are potentially off by making the wrong call, et cetera. And obviously there is a visual representation of this, right, that everybody kind of thinks about from like Jaeger, or we'll see it in Wavefront today. And it's a really useful representation. So tracing is sort of like I would say, the missing piece of that puzzle from an analysis perspective, right, when it comes in. It's not the whole thing, but it's one of the most important pieces because that's kind of where you'll potentially start. And we go use metrics and histograms and other data to help you analyze and correlate information. And when we think of these 3 bits together, right, at least, okay, we do here at VMware, right, we call it 3D observability, right, because there's multiple dimensions of solving this problem. You've got metrics that we're all used to, right? You're going to use some sort of charting, histograms in our case, and then tracing, which we're all kind of struggling with and trying to understand how to deploy it, how to use it, right? And so I think the big question, obviously, for today is, okay, so I've got a bunch of developers. They're going out and building all this. And they're always going to come to me because of all the different languages and everything that they've got. Okay, I've got a problem, right? You as a DevOps person have to now go deal with that. And tracing can help. But the big question is, obviously, what do I use? Where am I going to start, right? Okay, it's a huge ecosystem, lots of different things. Your head's kind of hurt, like which one works with what, etc. And, the way I think about this, right, and hopefully this helps you, is that if you think about all those bits that are out there talking about tracing, there's 3 baseline buckets here, right? One is the open source bits, right? Everybody knows Jaeger and Zipkin, right? Jaeger came from Uber Technologies, right? It's open sourced. It's part of the CNCF. Zipkin came from Twitter, right? It's also open sourced. They're both great. There's no right or wrong answer there in using them. It's just what you prefer. They all have a great following, great community, so lots of features are being added in, et cetera, right? It is open source. And if you think about the difference between them, the way I think about it is Zipkin's a little more akin to Docker. If you take Jaeger, a little more on the Kubernetes side, right? It's got a lot more bits in it that you can help you with that. And then you have the alternative, which is, look, it both of those require quite a bit of work, honestly, right? To get up and running, and you have the UI, you have to install it, you have to go through it. The alternative is to use a commercial-based implementation. And we'll talk about ours today, which is Wavefront, okay? And so you have these two mainline buckets to pick from, right? To kind of visualize, get information, collect it. Then you have another section that's now started, and a lot of people are looking at it, and that's open tracing and open census. And if you think of open tracing and census, the best way I can kind of convey that to you is they're basically a set of APIs and libraries and frameworks that effectively allow you to then swap out different bits and effectively allow you to be independent of any of those open source or commercial bits over time. Because things change, right? So you're going to make that choice, right? But if you do want to change, one of the best ways is to put in the baselines, right, with open tracing or open census. Now, open tracing is CNCF supported. Since open census came out from Google and it's still open source, kind of getting out there. Again, it's just a choice, right? I'm not going to advocate one or the other, but I think you guys can take a look through that and work through it. Now, a typical architecture that you would use in this is really as follows. You have your application. And if you wanted to use open tracing or open census, you would put those libraries into the application. It would then export a set of information that then can get attached to any one of those agents that Jaeger, Zipkin, or in this case we'll talk about Wavefront, right? It's going to pass it to a collector. The collector is going to gather that information. It may store it locally, and you have options there, right? What type of collector are you going to use? What type of backend? Or you can send it straight out to some SaaS tool like we have, right? And then you have a UI that can visualize this. So lots of different options and potentially combinations. And today, obviously, we'll show you the bits around what we have in Wavefront and show you how easy it is with that application that you saw, right? So hopefully you guys have been clicking. And so let's get into that. So that's a quick overview, a little bit of just a baseline for us to start. So I'll hand it over to Sushant here to go.
Hello. Okay. Can you guys hear me? Cool. Okay. Can you guys hear me? Awesome. So today what I'm going to do is I'm going to talk about the application that you guys played with when we started this presentation. So you guys saw this, right? This is the BeatShirts application that we have built, which we use to demo the power of distributed tracing. So the reason we call it BeatShirts is because it's based on this philosophy called BeatJobs. And actually, I'm wearing this T-shirt. I have to hide it behind my jacket. We have this philosophy called BeatJobs. So what we claim is, if you use Wavefront for your monitoring needs, Wavefront is the first-class true observability platform. So if you use Wavefront to monitor your application, if you are that on-call SRE person, right, you can do your work by sitting at the beach. That's where the whole BeatJobs philosophy was born. And based on this BeatJobs philosophy, we have built this BeatShirts application. And today you guys played with this application yourself before the presentation began. Some of you saw some random latencies in the application, right? Some of you saw your shirt's order was very quick. It was in the order of milliseconds. Some of the unfortunate ones saw some random latencies in the order of seconds. And that was deliberate because we wanted to show how we can monitor any random application using Wavefront. We also injected some errors in our application because we also want to monitor the errors that are coming from our application into Wavefront. So the whole reason for this is we want to show that this innocent-looking application that you see on your screen is actually powered by a very complicated microservices architecture. What if I told you that what you're seeing on the screen is actually this? What you're seeing on the screen is the same application that you just saw like 5 seconds ago. This is your polyglot microservices application. As you can see, you have all kind of technologies, all kind of frameworks, all kind of languages thrown out there. If you're married to Ruby, you see Ruby over there. You see Java, you see Python, you see Go. You're seeing Drop Wizard framework, you're seeing gRPC, you're seeing Django. And this is how this application was assembled. This application was actually built by a bunch of developers. and they had their own agenda. They were married to their own framework, their own technology. They made sure that their service works great, and then handed this thing, which is a spaghetti application, like I like to call it, to this on-call SRE, who did not write a single line of code. And this on-call SRE is now responsible to make sure that this application SLA is being met. And what's the SLA we are promising? The SLA we are promising is you order any shirt, we will deliver it to you in milliseconds. So this whole end-to-end workflow that you see on the screen should take milliseconds. But you already saw, some of you guys saw latencies in the order of seconds. So we have breached that SLA. So now, how can we monitor this application using Wavefront, which is what I'm going to demo today. So let me stop this presentation. And let me go to this particular browser. So this is the application that you guys played with, right? This is the browser-based application, and you can click on this. And what's happening here is it's sending live telemetry into Wavefront as we speak. So it is sending this rich data, the 3D data like we call it, right? Metrics, histograms, and traces. All are being sent from this application using our SDKs into Wavefront. So I go to Wavefront over here. This is our Wavefront UI. And what we have done is now we have promoted application as a first-class construct in Wavefront, because Wavefront is going to do application monitoring on your behalf. And it doesn't really have to be microservices application. Any application instrumented using open tracing or open sensors can be monitored using Wavefront. So I go to these applications, and I can directly jump to traces. So if I am impatient and I want to directly look at the traces being emitted from this Beachers application, I can click on this traces tab. But what I want to really do is I want to see what else is being emitted into Wavefront. So I'm going to click on inventory over here. So as soon as I click on inventory, I see that there are 3 different applications that are being monitored by Wavefront. The very first application is the Zipkin application. So what this means is this particular application was instrumented using Zipkin. This was sending data to Zipkin. And then we hot swapped Zipkin to Wavefront using a Zipkin integration. You didn't have to change any code. So if you have an existing investment in Zipkin, you can still continue with that. But instead of having 2 full-time engineers manage Zipkin, you can now send everything to Wavefront. The second application that you see is the Beach-Ops application. What is not evident on this application is that this was actually being monitored using Jaeger. And now using the Jaeger integration with Wavefront, we just swapped Jaeger with Wavefront. So now this same application, just one config change, instead of pointing to Jaeger, you're pointing to Wavefront. So if you have an existing investment in Jaeger, you don't have to get rid of that. So what the first 2 applications show you is that we are 100% compliant with Zipkin and Jaeger. If you're starting from scratch, right, if this is a greenfield opportunity, we highly encourage you to monitor this application using the Wavefront Open Tracing SDK. We are 100% Open Tracing compliant. So you can go here, and this particular application, this is that complex application that you saw on the PowerPoint. This is this Beachers application. What you're seeing on the screen is more than 3,000 requests were being made to Beachers application in last 2 hours. And some of those requests were being made by you guys. Out of that, the error percentage rolled up all the way to the application is around 6.45%. And the latency, the 95th percentile latency of all the requests being made to Beachers is around 3.89 seconds. So this is where histogram value is very important. What if I told you that the median or average is milliseconds, right? So in that case, the SLA is not breached. But the 95th percentile in this case is in the order of seconds. It's no longer in the order of milliseconds. So my SLA is already breached. I can actually now even sort it based on the number of requests. So you can see that Beachers is getting the most number of requests. I can sort it based on error percentage. I can sort it based on latency. So I know that the Beachers is the slowest application. What I can do next is I can click on Beachers, and I can see all my services in this application. So this is the same polyglot application that you saw. Oh. Sorry. Okay. So what's happening here? I actually got an alert from Wavefront sent to me via PagerDuty. And the reason for that is this particular application, SLA, is being breached. So as I monitor this application, what I have done is I have also set up alerting through Wavefront. And the alert target that I've set up is to my phone. And that's why this sent me an alert on my phone. So let's see what actually happened. I'm going to click on this guy, and I see an alert over here. So what this alert tells me is the 98th percentile of any request being made to my beachers is exceeding 4 seconds. That's the alert that I had set up. And that alert just fired as we spoke. So if I click on that link, right? So I'm just going to click on this link here, because it actually not only tells me that the alert has triggered, the SLA has been violated, but it also tells me which service is impacted. So in this case, the shopping service is impacted. So I click on that. And what I'm taken to is the dashboard chart. So this is my dashboard for the shopping service. So what it's showing me is my red metrics, my request, error, and duration for the shopping service. So I can see that roughly 9 to 10 requests were being made every minute to the shopping service. And out of that, I see some error spikes, right? Roughly 2 errors per minute. What is most important is this spike. So you see what happened over here. This is the 95th percentile. What this shows me is that my request being made to shopping service spiked all the way to 15 seconds. Keep in mind that we are talking milliseconds over here, right? We claim that any order that you make to the shopping service will be fulfilled in give or take 100 milliseconds. This has spiked all the way to 15 seconds. That's not good, and that's why I got that alert. Let's look at what happened, right? So this actually gives me the red metrics, and the chart below, this is the top case chart. So this gives me the top request, the corresponding top failed request, and the corresponding slowest request. So just by this particular alert, now I have linked to the dashboard. I know how my red metrics are doing. I know my top offenders, my top failed request, and my most sluggish request. Everything all in one place. After that, I know that the shopping service is built using Jersey framework. So I have all my Jersey metrics in the section below. So in this case, this is the subset of my shopping service, everything pertinent to Jersey. And similarly, all the Jersey API handlers, right? So any RESTful API handler, I have the same top request, the top failed request, and the slowest request provided for me. And I see the same spike over here as I see here. So what that means is one of my Jersey requests is taking roughly 15 seconds. That's not good. What I have next is I also have my drop wizard metrics. So this particular application was built using drop wizard framework. So I have all the KPIs for drop wizard being sent to me. So I have the Shetti metrics, I have the thread pool size all over here. And I can see that the servlet response is actually spiking up. So this is that same Shetti servlet that is actually going up. What is even cooler is now I also have the JVM metrics, corresponding JVM metrics for that time window. So if I go here, right, now I have my heap size. So you can see my heap size is also going up. So my heap size is going up as my latency is going up. So that's not good. And at the same time, my GC is going down. I also have my system metrics for the node where this particular service is running. So this particular service is actually running on a node, and I have the CPU usage of that node. I have the memory. So see, the memory is spiking at the same time as the heap is going up. So I can correlate different kind of sections for my same service on one single dashboard. And this is the power of 3D observability, right? So if you just use distributed tracing alone, if you're using Jaeger or Zipkin, that's a great start, right? It's zero investment if you think about it. You're not paying any money. But what you get, the value that you get out of it is just tracing. And this is where it's important to differentiate that versus 3D observability. Here you're marrying the concept of metrics, histograms, and traces, and sending all of it to one platform. And you really need that one single platform when you have to triage issues, just like I got this alert right now. So what I've shown you so far are just the two dimensions, metrics and histograms. You might ask, where are my traces? What I'm going to do is, I already know that this particular operation is spiking. I'm actually going to go to shopping service and order shirts. So if I click on, let's say, the order shirts over here, right? What I'm seeing is, now I'm seeing all my traces for the shopping service. So on this left pane over here are all the traces for the order shirts API. Let me click on this particular trace. This particular trace is taking 4.65 seconds, which is not good, right? An end-to-end trace is taking 4.65 seconds. So what that means is when you try to order shirts, you're going to get a response after 4.65 seconds. as opposed to milliseconds. Why is that? You can look at this trace and click on the corresponding service map. So this actually now tells me the service dependency map. So if I click on this, I can know now that who is calling whom. I can click on this and say that shopping service is calling inventory is calling warehouse, and styling is calling printing. So I clearly have the dependency map at hand. Not only that, I have all the KPIs, the health of the individual service on this map. So I know how is my shopping service doing with this red matrix. So I know that the shopping service was triggered 905 times in last 10 minutes, actually, in this case. And out of that, 98 errors resulted from the 905 request. Keep in mind that the end-to-end latency for shopping service was 9.5 seconds. What if I want to click on some other service, right? If I click on styling, notice the numbers are changing on the right. So now I know the health of the styling service. I know the health of the delivery service, the packaging service, the notification service, the printing service, the inventory service, the warehouse service. Look at the payment service. That is interesting. Just compare the payment service with the shopping service, right? Do you guys see this particular section over here? That's a hint to me that the payment service is misbehaving. What that means is the 95th percentile for the payment service is going all the way to 15 seconds. And what was the latency for my shopping service? It was 15 seconds. So maybe, as you can see on this diagram, that the shopping service depends on the payment service, and payment service is misbehaving, because of which the shopping service is also slowing down. What else can I do with this UI? With the power of histograms, now I can look at this particular trace, and I can figure out whether this trace is good or bad. So this particular trace is taking 4.65 seconds, right? Maybe 4.65 seconds is not that bad. It looks bad on paper, right? Because our SLA was promised to be milliseconds. But if you look at this particular histogram visualization, you can see that this particular end-to-end trace is greater than the 75th percentile, but is less than the 90th percentile. So it's not even the bottom 10%. So it's not that bad. Finally, I can look at an end-to-end trace, right? So what I'm going to do is, I'm actually going to look at this trace, because this trace is sticking out, right? All these traces are sorted by outliers. I'm going to look at this particular trace. This particular trace is taking 16.25 seconds. Compare that with this trace. So this trace is really an outlier. So why is that? And I can get that information by looking at an end-to-end trace diagram over here. So I click over here, and now I am seeing this end-to-end trace, right? This is the power of instrumentation. You might ask, like, okay, this is great for a demo, right? But as a developer, how do I get this same information? How do I get the same UI? As a developer, all you have to do is you have to diligently instrument all your services. So in this case, if this is your service, right, or your application composed of different services, you have to make sure that you instrument your application end-to-end. All the services are instrumented. All the services know how to talk to each other, right? The context is propagated correctly. That's when a true end-to-end trace is sent to a platform like Wavefront. And that's how you get this out-of-the-box experience. So the onus is on the developers, or the service owners, as I like to call them. So let's look at this particular end-to-end trace, right? This particular end-to-end trace is taking 15.19 seconds, right? So just at first, it's easy to blame the shopping service. You might even get an alert saying that the shopping service is slow. But in reality, why is the shopping service slow? You look at this guy is calling shopping get, and it's calling inventory. That call is returning very quickly, right, in less than 1 milliseconds. So clearly the bottleneck is not in the inventory service. Then something interesting is happening. Shopping service is now trying to call the payment service. And it's trying to go to the order is going through the payment. So you're trying to pay for that shirt that you tried to order. And it goes to the process payment. So process payment takes around 15 seconds. The process payment calls another method inside the payment service, which is authorized payment. Notice how long the authorized payment service is taking. It's taking 15 seconds. Now you know what's slowing down the whole workflow. The whole workflow is slowed down because of one bottleneck. And you know that now because of this orange line that tells you the critical path for an end-to-end flow. So you might ask, okay, now that I've pinpointed this is my service that is slow, or this particular operation is slow, why do you think that's slow? And the way to find that out is you click on this, and now I have all the metadata for that particular operation. I know which service it belongs to. It belongs to the payment service. It came from the Beachhead's application. I also know which cluster it was deployed on, what shard it was on. I have other metadata as well, right, other tags. I know what environments, in this case, this is production, so that's not good. I also have the span ID, the trace ID, and its parent ID, and I know that this is an erroneous span. So I have all this information. But that still doesn't tell me why is this slow. And the way to find that out is to click on this link. And if I click on this link, what I'm getting is I'm getting the logs. So I'm getting the span logs associated with that particular span. Now this is where we're combining not only 3D observability, which is metrics, histograms, and traces, but we're also bringing in logs into the mix. And this is a very specialized form of logging. This is logging with respect to spans or with respect to the traces. So if I click on this particular span, I know that this span is taking 15 seconds, and the reason for that is it resulted in a timeout exception, which the service owner diligently logged and sent it along with the span and the trace to Wavefront. And just by virtue of instrumenting that particular call, now we have everything in one place out of the box for you. So now you know that this particular operation timed out, which is why this particular end-to-end flow took 16 seconds as opposed to milliseconds. So this key piece of information is something you would not have if you do not instrument tracing. So with this, I hope the demo was like a good eye-opener for you guys. If you're developers, the next step for you guys would be to make sure that just the way you log something is one of your debugging tools. Always think about, can I instrument this method for tracing? Can I emit a metric out of it? Can I emit a histogram? Because all these things together, when you emit something to one platform, will give you true power to debug and diagnose the problems in your application. Because keep in mind that you are, as a developer, you're not the person who is going to have to stay awake to monitor your application. There is some third person, the SRE, who didn't write a single line of code, and we have to empower that SRE with these tools and with your instrumentation so that that SRE, when he gets that page, tries to resolve that problem as soon as possible. So with that, I think I will like to call Bill again to the stage to conclude. Oops, sorry. Let me just get to the correct slide. 1 second. Demo. Let me get my water.
Okay, what'd you guys think? Interesting? We'll take questions in a second. Got to put this in. Marking guys are here. It's not saying anything. Go to, if you like the tool, obviously it is really cool. It's got a lot of great features. Go to wavefront.com, sign up for a trial. It's free. I think I want to leave you with this also, right? Is that, look, tracing is hard. This is not easy, right? But we have a tool that can help, right? That can bring a lot of these things together. And, you know, it's things are constantly changing, right? I think the place to leave it at is, look, whatever we even talk about or I've talked about before and a couple other meetups is that, you know, there's now this new thing called open telemetry that's out there merging the two together. And so, you know, if you adopt like an open framework underneath, you'll be able to swap things out or use a commercial tool like we've showed you with all the great features, right? The thing is that you have an option to go flexible, right? But think about it as a journey, right? This. Keep in touch, and we'll take questions, I guess, right now.
I think that's a great question, right? So let me ask you, or let me ask the developers in the room, is there any reaction or resistance to emitting a log statement in your application or in your code? That's the first thing that is taught in school, right? As in, obviously, you can manually debug your code, but make sure you have enough logs in your code. I think the analogy is similar. Logging is a thing of the past, right? Or it's really like just logging itself doesn't really help you. So now, just that there is no resistance for logging, I think the culture is changing, and now there is not a lot of resistance to instrument your service for tracing.
Yeah.
think it's a no-brainer if it's a greenfield opportunity that you have to. But for brownfield, I agree, there is some resistance because you have to go back in time and instrument your code, and that's always a pain.
Yeah, I mean, it's just good hygiene now, right? It's going to get there. Like, I mean, it's not probably relevant. Yeah, you're right. They're going to say, like, what? It was sort of like when logging, we're still kind of getting in, and it's part of the libraries. Now it's so easy, right? It's going to be there soon. So I think you're going to have to put it in procedures and push it back down. That's just part of life. It's the cycle. Anything else? Go ahead. That's a great question. I've not even thought about it from that down level. You want to take it? Okay. That's a great question.
So I have a perspective. I think the power of this notion of 3D observability is the ability to correlate data from everything. So in a former life, I was a network engineer. I'm now more of an infrastructure operations guy. And when a thing breaks, I want to know everything around that thing that broke, because I'm really focused on what broke and how fast can I figure out what broke. That mean time at WTF. So the more data I can consume, the faster I can figure out what broke. And one of my core thesis is you can run a 5.9 service on 3.9's infrastructure if you can shorten the debugging window. Because fixing it's usually easy, but figuring out what broke, that's where you spend a lot of troubleshooting time, right? So I think when I think of 3D, I'm taking in telemetry from my application, from my infrastructure, from everything around the ecosystem, and putting it into a chart and then making sense of the data.
By the way, he's the founder of BeachOps, so the whole BeachOps was started by him.
Yeah. I mean, from that perspective, you have the information to do it right now, right? You can use Wavefront from a correlation. And I know your question was, will the libraries here go extend? I don't know. That's a harder question. I haven't dug down. Maybe somebody else knows the answer, right, with open tracing or census or whatever they're coming up with now, right? But I think, he's right. At the end of the day, you have the data. If you look at the tool we have, that correlation capability is there. You can get the tracing on the servers. If you take a look at Wavefront, I'll tout the product, but the point is that you can take that and correlate it down to the EC2 instance that it's running on, right? You can just say, find this based on some tags or whatever information. You can get that. It takes a little bit of work, but I know where you're trying to head to, right? But I think you can get it right now. And it's actually fairly simple in Wavefront, right?
So because I think this is like a real-world example, too. We've had issues where things are slow, and it's actually the network. I'm dropping packets. And that, even in 2019, we still run on a network, and who instruments that, right? But if you have that richer telemetry from that layer, that often impacts everything up the stack. And if you're just an app guy, you don't really think about that piece. But if you can pull in, the load balancer is actually the constraint, and the impact it has on the app or the user performance, because all we care about is happy users. Right, so it's really, I try to pull everything into that piece as well.
Well, I think we are compliant with open tracing, right? So at the end, it's CNCF, right? We're not going to push one or another. What I said in the beginning was it's a choice, right? Even in what we have, you can use our own agents without any of it, right? It's just giving you the options and the knowledge. That was the whole point. You have that optionality, right? But I think at the end of the day, that information will bubble up. Where you choose to actually analyze it, that's going to make the difference for you right now, right? Yeah.
Yeah, so actually for Wavefront, right? Yeah, for Wavefront, you already saw the Zipkin application, you saw the Jaeger application, and you saw the open tracing SDK application, right? So for us, we don't really care where the data comes from. We're 100% open tracing compliant. We're 100% open census compliant. What we truly care about is the instrumentation experience. You have to instrument your application end to end. And once you send all the atoms to Wavefront, right, when we try to blur the lines between metrics, histograms, and tracing, that's where you can truly leverage the power of an observability platform like Wavefront. So we essentially, tomorrow when OpenTelemetry becomes mainstream, we'll be 100% compliant with that as well. So we don't have a bias as such towards one open standard versus another. And regarding your earlier question about infrastructure monitoring, right? Like the analogy that I think about this is what you saw today was top-down monitoring, right? So you saw something all the way from the application. You drill down into services, and you drill down into individual service, and you see different dashboard sections or different components, right? I like to think about that as top-down monitoring. You can also go bottom-up monitoring, which is the infrastructure view, right? So you can start with your Kubernetes pod, and you can go like bottom-up if you want. And Wavefront has first-class integration for Kubernetes as well. So it doesn't matter if your application is running on EC2, Kubernetes, or bare metal. Like we can monitor all of it.
Anything else? Okay. Thank you.